The team goes to work, bringing together all the information they had collected independently into a single comprehensive study. Jonathan and Doug's plesiodeipiform skeletons, Mary's scans of dozens of ancient skulls, and Eric's anatomical data on a close living relative, the tree shrew.
The way we start is by comparing all these specimens.
Detail by detail, feature by feature, they combed through all the data using a numerical system to compare and contrast.
After we studied the different characteristics of these animals and reduced them down to numbers, absence of a nail is a 0, presence of a nail is a 1. We then ran this through a computer algorithm.
The algorithm sifted through the complex data in search of simple relationships. Which fossils have the same characteristics, the same numbers? Using this information, the computer was programmed to create family trees, illustrating the potential relationships each mammal has to the next. The team expected the computer to come up with several possible scenarios in the form of several possible family trees. Instead, the program came up with only one.
Oh, yeah, I see. I was a little surprised to see it so unambiguous.
This single family tree could lead to only one conclusion.
I think the evidence as it stands today is pretty compelling that, yes, in fact, these are primates.
Every new piece of data that we had coming out of our study of this material seemed to be consistent with that idea.
Not only that, one of the plesiodeipiform skeletons Jonathan and Doug painstakingly etched out of limestone, a species by the name of Dryomomes, turns out to be far more primitive than the other two, possessing only one primate characteristic, the shape of its teeth.
It's sort of a transitional specimen between more primitive things like tree shrews and later primates.
One part primate, other parts not.
I mean, it really starts to tell us something about the base of the primate tree, what the earliest primates look like. So if we're one leaf on the branch, so are chimpanzees, gorillas, orangutans among apes, all the different monkeys in the Old World and the New World, lemurs from Madagascar, lorises and galagos, all of those animals are living today, but you can trace it all back to a single common ancestor. And as you get closer and closer to that common ancestor, Dryomomes is one of the animals that's closest to the base there. It's the most primitive primate skeleton ever found, to date.
Jonathan had evidence to support his theory. Primates didn't just appear on the planet, they evolved over a 10 million year period. And just as he thought, the earliest primates were the size of a mouse. Still, one question remains. What sparked this amazing transformation? The team believes our ancient ancestors evolved on the heels of a mass extinction. Without the mighty T-Rex around, the tiniest of mammals are free to forage and explore. And they discover a world filled with flowering plants and succulent fruit.
We have this sort of coevolutionary relationship where fruits were evolving to get tastier for primates to eat. The primates were then eating them and helping the plants actually spread their seeds further.
With tempting fruit growing at the end of tiny branches, our ancestors have plenty of motivation to change. So they begin to evolve, developing long fingers for climbing trees, specialized teeth, hands and feet uniquely designed for grasping and eating the tiniest tasty berry. Over 10 million years, they slowly develop unique characteristics that we recognize in our primate relatives and ourselves.
So that if plesiodeipiforms don't evolve, then we're probably not standing here talking about this right now.